Welcome dear students. Moving on further, in this video I will discuss the motion of a particle, how we can calculate the motion of a particle. So let us start. Determination of the motion of a particle. So generally we used Newton's law F is equal to ma to calculate the acceleration. So in that case we need to know the force, but that will be covered in the kinetics part, since we are first dealing with kinematics and where we do not consider forces. So generally there are three classes of motion. The first one, acceleration, can be given as a function of time. Then we can treat acceleration as a function of position, and the last we can treat acceleration as the function of velocity. Now can you tell me an example when the motion of force is a function of position? Just think. So the example is a spring. So when you compress an spring, so the force which is applied is the function of position, F is equal to kx. Okay. Can you think of a example when force is a function of velocity? So drag force is the function of velocity. If the particle is moving at a very fast speed, then the drag force will be more, and if the particle is moving at a slow speed, then drag force is low. So in this case, force is a function of velocity. Now in this slide we will see acceleration as a function of time, position, or velocity. So consider this table. So here we have acceleration as a function of time, position, and velocity. So first we will see the kinematic relationships, and then we can see how we can calculate the motion. So all of you know that this expression, acceleration, is a function of velocity, and this is the relation A is equal to dv upon dt. So this is the kinematic relationship, and when you will integrate this equation, what you can do, just take dt here and just integrate from the initial position to the final position. That means from 0 time to the t time. So by solving this equation, you can calculate the velocity. Okay. Now the second option, acceleration is a function of position. So we can do this. We have two kinematic relationships. V is dx by dt and A is dv by dt. So by combining both these relationships, we will get v dv is equal to ax dx. So this is the relationship for acceleration as a function of position, and what you can do, you can simply integrate this, and you can get the velocities and positions. Okay. And the third option is acceleration as a function of velocity. So in this we again use this first relationship, dv by dt, and in this case a is the function of velocity. So you need to integrate again. So this time we have not taken this t here, because now acceleration is the function of velocity. So you can clearly see the difference between this equation and this equation. Here, because the acceleration is the function of time, so we have taken a towards here. But in the third case, since we are assuming that acceleration is the function of velocity only, so in this case acceleration will remain on LHS. That is, on LHS we have dv upon a as a function of v, and on the RHS we have dt. So again, by integrating this, we can solve for the motion, and Second equation we have, this equation we can obtain from this equation, v is equal to dx by dt, and by using the product law you can get v dv by dx as a. And again you can integrate, you can take the terms related to v on the RHS and x on the LHS, and when you integrate this you can obtain the motion. Now let us do an example. So this is the problem. Ball tossed with 10 meter per second vertical velocity from window 20 meter above the ground. So here we are having a window, and from this window we dropped this ball with a velocity of 10 meter per second. And what we need to find? We need to find the velocity and elevation above ground at time t. So after time t, what will be the velocity of the ball, and what is the elevation of the ball? Second is unknown as highest elevations reached by ball. How much is the highest elevation that ball can reach and at what time? Third unknown is time when ball will hit the ground and the velocity with which the ball will hit the ground. Okay, so how we can solve this problem? We can integrate twice to find the v and the position, velocity and position, and then we can solve for t when velocity equals 0, so that we can find the highest elevation, because at the highest elevation velocity will be 0. So v equals velocity equal to 0, and then we can solve for t. And similarly, when then we can calculate the altitude. And to obtain the third part, what we will do, we will solve for t when altitude equals 0, because when ball hits the ground and the elevation will be 0. So this is how we can work. So this is the solution. So since we are assuming that acceleration as a function of time, so this will be the our equation. Acceleration is dv by dt, and we know that the acceleration due to gravity is 9.81 meter per second square. So we have selected this value, and since the ball is tossed upward and acceleration will act downward, so that is why this negative sign. So what you need to do, you just simply put this value and take dt here, and you just need to integrate this equation. So this integration is quite straightforward. On the LHS we will have Vt minus V naught, and on the RHS this is the constant. So when you put the limits you will get minus 9.81 T. So this is how you can calculate the velocity as a function of T. Now we know that it is 10 meter per second, so we can take it on the RHS. So this is our equation, Vt is equal to 10 meter per second minus 9.81 meter per second square into t. So this is the equation, this is our answer, the answer to the first part. And for obtaining the position, you simply need to write this equation, v is equal to dy by dt, and we already obtained the expression for v. So what we will do, we will take t here on the RHS, just here. We will take t here. So this is 10 minus 9.81 t into dt, and on the LHS we have dy. Just integrate this, then you will get this expression, yt minus y naught is equal to 10t minus 1 by 2 9.81 t square, and since the initial height is 20 meters, so the final expression will be yt is equal to 20 meter plus 10 meter per second t minus 4.905 meter per second square t square. So this is how you can calculate the expression for velocity and expression for position. And on the LHS, these are the graphs for V versus T. So V versus T graph you can obtain from this equation by simply putting different values of T. So when T is 0, so initially we are having velocity as 10, okay. And when you put different values of T, you obtain different values of V, and you simply mark the point and you will get this curve. And similarly for Y versus T, this curve is obtained. Now to obtain the second and third part of the problem, so what you need to do, you will simply solve for T when velocity equals 0, so that you can calculate the corresponding altitude. So this is our equation for V. V is equal to 10 minus 9.81 T. So we will put this as 0 and we solve for T. So from this equation, T will comes out to be, uh, you simply take it to the RHS. So T will be 10 divided by 9.81. So this into, okay, so T is 1.091 second. Okay, and when you put this value of T in the equation of Y, this is the equation of Y, so simply put this value of T and solve. Okay, then you will obtain Y is equal to 25.1 meter. That means that the ball will go up to the height of 25.1 meter. So this is the solution of first part. Now to solve the third part, that is when ball will hit the ground and the velocity with which the ball hit the ground, we simply use this equation of Y. So when ball hit the ground, then obviously this Y will be 0. Okay, so we put Y 0 and we will solve this equation. So this is a quadratic equation, so it will have two solutions. So first solution is minus 1.243, which is meaningless because time is always positive, and second solution is t is equal to 3.28 second. So this is correct. That means the ball will hit the ground when after the time of 3.28 second after the release of the ball. Now to find the velocity with which the ball hits the ground, we simply use the equation of V and we put this value of V here. Okay, and we will obtain minus 22.2. That means the ball will hit the ground with a velocity of 22.2 meter per second in the downward direction. So this is how you can solve the problems related to motion. Now we will solve another problem. So the problem is in front of you. We have a car that starts from rest and accelerates according to the relationship. So we are given that acceleration is the function of velocity, and this is the expression a is equal to 3 minus 0.001 v square. Now it travels around a circular track. This car travels around a circular track, and the radius of the track is 200 meter. Now what we need to calculate? We need to calculate the velocity of the car after it has traveled halfway around the track. And what is the car's maximum possible speed? Okay, so let us solve this problem. So how we will proceed? First, we'll find which relationship will exist. So first we need to determine the proper kinematic relationship. Okay. Then next we will determine the total distance traveled by the car. Means in order to take the halfway round, how much distance will be traveled by the car. And then we need to integrate the velocity. So this is how we will. So we need to choose the proper kinematic relationship. This is the car, this is the track, and we are given that a as the function of v, initial velocity is 0, and radius of this track is 200 meter, and we need to find v after half lap, and we need to find the maximum speed. So acceleration is a function of velocity, so this is already given to us as you can see in this equation. And we can also determine distance from velocity, and time is not involved in the problem. Okay, so time is not involved, so we can choose this relation. Okay, and we need to simply integrate this. So what we do, we will put this expression here. So on the RHS we have terms related to v, on the LHS we have terms related to x. So after integration we will obtain some expression. Okay, so we will do it. Now to calculate the total distance, so simply this is a circular track, so in the half means if you want to cover half, so it is half of the circumference, so total circumference is 2 pi r, so half distance will be this half of the circumference, that is pi r, so this is 628.3. Further solution include determining the full integral with limits. So this is our integral, and what we do, we will put the limits. So these are our limits. X naught is 0, and x is this 628.32, and for velocity the limits are 0 to v, and here we will put the expression for acceleration which we obtained in the previous slide. So that is 3 minus 0.001 v square. The next step is to evaluate the integral and solve for v. So we need to solve this integral and we need to find the value of v. Okay, so these are the steps which you can follow to solve for this integral. So LHS is quite straightforward. You will get the value of 628.32 minus 0, which is 628.32. In the RHS we will got like this. When you integrate this, you will obtain this solution. You just need to put your knowledge of engineering mathematics, which you learn in first year, and this integration you also learn in your +2 level. And now we put the limits in this step, and finally we obtain this ln 3 minus 0.001 v square will be equal to minus 0.15802. Now you simply need to take the exponential of this, then you will get 3 minus 0.001 v square will be equal to exponential of this. And let us move. So this is our equation From this equation we can easily obtain the value of V. So V comes out to be 46.3268 meter per second. Now next step is to determine the maximum speed of the car. Okay, so how we can determine this? So for maximum speed, velocity is maximum when acceleration is 0. So this we already know. So if we want to find out the maximum velocity, then we need to put the value of acceleration is 0. So we already have this equation. In this equation, we will put the value of acceleration as 0 and then we will solve this equation. So we will get this, and when we solve this equation, then we get the maximum velocity as 54.772 meters per second. So this is how you can solve the problems related to kinematics. So that's all for today. Thanks for watching. Have a nice day.